To justify our use for of Black's model for to price swaptions, it's good to first review some of the previous lecture materials under the equivalent martingale approach. In earlier lectures, we talked about that if we have an ST, which is the forward swap rate observed at T, for a swap that have where the rate is fixed at T, big T 0, with payments coming at T1, T2, and so on. And for that particular swap, with this forward swap rate, we can see that the value on the floating side will be this, and the value on the fixed side is S times A. And we establish a ratio here. Basically, this ST, the swap rate, is this thing divided by the annuity. Okay, and then we establish, because we established the ratio, we call this, F, and the annuity G. Then we establish that the forward swap rate is really the expected future or the expected realized swap rate in the future. Okay, so take a look at those earlier videos on this particular subject, and it will help you understand the following material where we're gonna justify the price for swaption. Now, if we use A the annuity as a numeric asset, so any financial asset will have this particular expression under that equivalent martingale model. So basically, the price of the financial asset divided by A at time equal to 0 will equal to expected value of FT divided by AT. Okay, now, and where the expectation is taken consistent with the measure that A is used as the numeric asset. So that applies to any financial asset. It also applies to the swaption that we're looking at. So the swaption will also have this particular expression. Now, if we substitute the payoff of the swaption here as the FT, which we can do that, the initial value of the swaption, which is this F naught here, F naught is equal to this thing, is equal to this, where A naught is basically, just the A here, which is this annuity factor here. And AT is then where the coupon, zero coupon bond price is from T to TI. A naught is here with the summation here that the zero coupon bond price is from 0 to TI. Okay, now, so we just a straight substitution here, and after substitution, you will realize that this AT and this thing here will cancel out. Okay, so in the payoff here. Now, we're only left the yellow part of this FT. So then this expression becomes this expression. You pull the L out as a constant, so L times A, and expected value of this part. Okay, max xt minus xk or 0. Now, you have this, and if S, the forward swap rate, follows a log normal process, this thing here will become this, We have seen this several times, right? For a process that follows a log normal process. Now, then we have this expectation. The expectation is with annuity factor as the numeraire. So what is this expectation? Well, we know that from the review that this thing is just the current forward swap rate. So the expected realized swap rate at maturity time t using the annuity as the numeraire, that particular expectation is the current forward swap rate. So then you just substitute this forward swap rate to here. Then we will have this formula here. So essentially, this justifies, how we can use Black's model to price swaption. So we can do this for a formula where the underlying asset is pay fixed swap. We can go through exactly the same approach and the same analysis to, very similar to this. Just put in a different payoff function here. You'll get a different expression here, and then you will get a different formula for a swaption where the underlying asset is a receive fixed swap as well. So you should try that as an exercise.